Good morning. Good morning to everyone. Before starting class only they will give how it's possible. Good morning. All of you are here. So how you people have performed the exam yesterday? How it was? Hmm? It was very easy, right? No answer? Okay, nice. Okay. Okay, some people nice, some already has written okay. Okay, fine. So if you have performed very nicely in the exam, then it will be very nice. Okay. So what I will do is, by the time your friend come back to on live class, I will give overview whatever I have taught in the last class. Okay. Now in the last class once again we have done with the classification of colloids. Right. So that is with respect to which and all colloids we have done. One is multimolecular. What we have done is one is multimolecular colloids. So next one is associated colloids, and the last one is macromolecular colloids. Right? So many of the sulfur salt, gold salt, everything comes under multimolecular colloids. Now when it comes to associated, best example was micelles. So for associated, I took the examples of micelles. And when it comes to macromolecular, it can be a starch solution, which can be the example for macromolecular colloids. That's what we have discussed, right? And more about micelles we have discussed in the last class, where we have discussed about cleansing action of soaps and detergents. So soaps and detergents. Now what is the difference between soaps and detergents? Normally soaps are salts of the fatty acids, and when it comes to the detergents, they will be having long chain hydrocarbon with one terminal as polar region. The compulsory is that there cannot be a fatty acid when it comes to detergents, because there is no carboxyl, right? So that's where we have discussed about these concepts in our last class. Then we have discussed about Braddock's arc method for the preparation of colloids. Then we have discussed about Braddock's arc method for the preparation of colloids. Now today we are going to start with another method in the same thing for the preparation of colloids only. We are going to discuss with another one, that is nothing but chemical method, that is related to chemical method for the preparation of colloids. Fine. Now when it comes to the chemical methods, I have AS2S3. I have the molecule AS2S3. Okay. So now this molecule, when it is treated with water, sulfide with water, arsenic sulfide with water, now it will get converted into sulfur and AS2O3. That means sulfur will become free, and whatever molecule arsenic is that, it's going to make the bonding with the oxygen. That's where, okay. So here it should be H2S, hydrogen sulfide. Here it should be H2S, hydrogen sulfide. 1 minute. I had written water, it's hydrogen sulfide. So that's where I am going to get. Earlier whatever I had written was correct actually. Okay. Now there will be AS2S3 plus H2. Okay. So that's where we have the reaction. So where arsenic oxide with hydrogen sulfide will form arsenic sulfide and water. So that's where it's going to involve in the colloid solution. So one of the method. Whether equation is balanced? No. Equation is, or it may not be balanced. We will cross check. So when it comes to the metal, yes, it is balanced. So when it comes to oxygen, that's where it is not balanced. So here it is 3. So with time being, we will make it as 3. So don't write. For time being, we make it as 3. Now hydrogen got disturbed. So here it is 2. Here it is 6. So 3 2 are 6. So okay, fine. I think it is balanced because even sulfur is 3 here and it has become 3. So that's where we have got the solution. Means colloidal solution. Okay. So that is one of the method for the chemical method for the synthesis of colloids. One of the method. Okay. So same way we can go with other methods also, where hydrogen sulfide can be treated with water, or hydrogen sulfide can be treated with sulfur dioxide. There are many methods. Okay now. So now hydrogen sulfide, when it is added with sulfur dioxide, now there will be formation of sulfur salt. Okay. Now another product, naturally it should be water. So whether equation is balanced, we will cross check. So hydrogen, yes. Oxygen is not balanced. So why I am taking hydrogen first? Because only once in left hand side, once in right hand side. Then I talk about oxygen. Why? Only once here. But sulfur is occurring 3 times. So sulfur will go it later. We'll balance it at the end. Because we have got even pure form of sulfur also. So no need to worry about the sulfur. Now here it is 2 oxygen. For time being, I will make it as 2 here also. Naturally hydrogen got disturbed. So 2 2s are 4. I will make it here also 2. So in that case, total sulfur will be 1 and 2. It will be 3. So I will write it as 3 here. Now I think it is balanced. That's where we have the balanced equation. Right? This is sulfur salt. This is an example for sulfur salt. Preparation of sulfur salt. Okay? Got my point? So same way we have AuCl3, auric chloride. We have AuCl3, that is nothing but auric chloride. When it is treated with formaldehyde, I am talking about preparation of gold salt. I am talking about the preparation of the gold salt. So in the presence of water, now there will be formation of a gold salt. So naturally, as we have sulfur salt S here, for gold salt it should be Au. That's where we have the colloid solution. Okay. Now another product will be formic acid. Another product should be formic acid. And naturally, since chlorine is present on the left hand side, right hand side chlorine should be there. It should be present in the form of HCl. It should be present in the form of HCl. Fine. Whether equation is balanced? No. So first we will go with gold. So left hand side 1 gold, right hand side also 1 gold, and we should not worry about the gold at this moment. Why? We have got pure form of the gold here in the product side. So we will go to the next one. Less occurring element is chlorine after the gold. So I have 3 chlorine on the left hand side. I have only 1 chlorine for time being. So don't write. So for time being we will make it as 3 HCl. Fine. Now we will go with the next less occurring element, that can be oxygen. Here it is 2, there it is 2. That is fine. Now we will come to hydrogen. 1, 2, 3, 4. Left hand side 4, but here it has become 5. So 3 and 2, 5. Now the problem here is there are even number, there is an odd number. Right? Even number is present here, there is odd number which is present there. Now we have to make something. So 3 is not going to function. So what I will do is, for time being I will make it as 4. We will try to balance it. So if I make it 4, so 4 and 2 it will become 6. So now 2 and 2 here it will become 4. In that way, if I am going to add 2 here, alright, 2, 2 and 2, it will become 4. Okay, fine. So I should add 4 here. Now the problem if I add 4 here is carbon will get disturbed. So right, carbon will get disturbed. Even I have to change the carbon here also. During that time, even hydrogen will get disturbed. Okay, now even this is not going to function. So we will move to the next number. It can be 6. We will move to the next. Don't worry about this one, because if I am disturbing this one, no need to worry, we can balance the gold, because as a single element it is present there. Okay. Now if I write 6 HCl, now I have got total 8 hydrogen. I have got total 8 hydrogen. So here how many hydrogens are there? 2 and 2. 4 hydrogens are there. So what I will do is, here I will make it as, so since oxygen single it is there, so here I will make it as 3. 3 2 just 6 and 8. Okay, fine. Here it became 8. Now oxygen is becoming 3 and 1 4. Here it is only 2. So naturally I have to disturb this particular formula. So in that way I will make it as, 1 minute, no one should write. 2 2s are 4. 6 3 2 6 10. So oxygen, so that it is 2. 4 is there. Okay. I think it's got balanced. Just cross check whether it is balanced. I think it is balanced. Only thing is here we have to write 6 gold. Okay, fine. I think it is balanced. Right? So just cross check whether it is balanced. If I see the carbon 3 and 3, if I see oxygen 3 and 3 6, here also 3 and 3 6. So hydrogen is Muralaru or 112. So Muralaru after 12. I think it is balanced, right? Okay, here chlorine is not balanced. So I will make it as 2. So here also I will make it as 2. Yes, now it is balanced. Yes. Fine. So that's where we have the formula. It's not AuACl3 Varshita. It should be AuCl3. Okay, yes, it should be 2. Done. So I have written here. Okay. So this is where we have another method for the preparation of gold salt. Another method for the preparation of gold salt. Next one is ferric chloride when treated with water. Ferric chloride when treated with water. Now some of the equation we can write it easily, no need to by heart. So what I will do is, don't write like this. So I will make it as water like this. So where I have positive and where I have negative. So in that case I will take one positive, one negative. So here also it should be positive and negative. Now it's very simple. So positive will go with the negative and negative will go with the positive. So that means whatever OH minus is there, it will go with the positive, and whatever H plus will be there, it will go with the negative. So what will be the product? So product will be Fe. If I observe, whatever I have written is ferric chloride. Whatever I have written is ferric chloride, right? Where ion will be in +3. Where ion will be in +3 oxidation state. So therefore ferric hydroxide should be the product, right? Where each hydroxide will be having -1. So the formula should be FeOH thrice. So what should be the another product? What should be the another product? Another product should be HCl. Another product should be HCl, right? And this is the one, ferric hydroxide solution is the one which will form the colloidal solution. Now once again we will check whether it is balanced. So if I see the metal, yes, it balanced. Next comes the oxygen or chlorine, anyone I can take. So chlorine, it looks it's not balanced. So for time being I will make it as 3HCl. For time being I will make it as 3HCl. Now if I see the oxygen, even the oxygen is not balanced. I am not going with hydrogen because once here, 3 times in the equation hydrogen is coming. So I should go for hydrogen at the end. So before that oxygen I should give the preference. Now when it comes to the oxygen, here it is 3. So I will make it as 3. Don't write, we will see. So I will make it as 3. That's where I have the oxygen which is balanced. Now we have to see what about hydrogen. So 3 2s are 6. Okay, naturally it is balanced. Hydrogen by itself it has got balance. That's where we have got the equation. That's where we have got the equation. Now if I observe the first one, there is a displacement, right? So oxygen got displaced by this sulfur and sulfur got displaced by the oxygen. That's where it is double displacement, where non-metals are getting displaced. So it can be double displacement with respect to non-metals. Sometimes they will call it as decomposition also, that is fine. Since non-metals are used, sometimes they will call it as decomposition, right? If I see the next one, so oxygen is in -2. So here it is +2. Okay, plus 4. Here it should be plus 4 because oxygen is minus 2. But here it is becoming 0. Here it is becoming 0. Oxidation state of sulfur is getting changed, right? So minus 2 plus 4, 0. So that's where we have the, once again it can be called as a decomposition only. So redox reaction, more than one oxidation state, naturally it will be called as double decomposition. But if I go with this one where it is with minus 2 and here it is becoming 0, I can call it as oxidation. Fine. So this is another one. If I see this reaction, where it is nothing but plus 3, gold is in plus 3, in the product it is becoming 0. So what is happening? There is a reduction. So reduction of gold particle is happening. So in this case it is pure case of hydrolysis. This is a pure case of hydrolysis where water will be split into H plus and OH minus, and that's where product is also getting hydrolyzed. That means hydrolysis, product is getting split into two parts due to the hydrolysis of water. So therefore it is a pure hydrolysis case. Okay. So that's where we have the some of the reaction where we can see oxidation, decomposition, reduction or hydrolysis. There are many methods by which we can prepare the colloidal solution. Okay. So these are the some of the examples. I think I have covered whatever is there in your, yes, I have covered whatever is there in your textbook. That whatever chemical method is there, I have covered. This is where another method for the preparation of colloids. Okay. So now try to remember the reaction. They have not asked about this, but try to remember, it may helpful for your competitive exams. Okay. Now we will come to next one. I will write it as just important, that's all. That is nothing but peptidation. We have to clear the word. Radix arc method already we have done. Now we are moving to the next part, that is called as peptidation. Now what do you mean by peptidation? Peptidation is nothing but, so HCl, 3HCl, okay. Your people are talking about equation, fine. So when it comes to peptidation, so it is the process where a precipitate will get converted into colloids. So peptidation is a process. It is a process when or during which a precipitate will be converted into colloids. Precipitate will be converted into colloids. So that's where we have the peptidation process. Normally it will be done by adding the electrolytes. So whatever peptidation is there, it is a process of converting a precipitate into colloidal solution. Normally it will be done by adding the electrolytes. Now what will happen? Normally a colloids, try to understand this concept because it's going to be a bit important for your competitive exam also and board exam also. May not be peptidation, I am talking about whatever I am going to explain now. Now normally colloids will have charges on their surface. Either it can be positive or it can be negative charge. So if I take negatively charged colloids, that's where I have got the negative charge. Now due to negative charges on their surface, they will be repelling each other. They are not going to clump with each other. Now very simple example, if you go back to day-to-day life, Biology students will be knowing. We have got one of the cell called as RBC, red blood cells, right? So red blood cells, they are present at very high concentration. They are present at very high concentration, right? So if I take these red blood cells, still if they, although they are in high concentration in the blood, still they will not get clumped. If that one happens, a man is not going to survive. Fine. So the reason is very simple, because they carry negative charge due to the membrane protein. So they will carry the negative charge. That's why they will repel each other. They will stay separate only. Although in a small volume, in 1 microliter of blood, we can have around 3 millions. Can you imagine? 30 lakhs approximately RBC in 1 microliter. So, but still they are not going to get clumped. So that is due to the same charges present on the surface. Now, what I will do is I will add some amount of oppositely charged electrolytes. I will add opposite charged electrolytes to the solution. Now what will happen? Some of this negative charge will get replaced, or it will be counter-ion by the positive charges. So now the molecule will become neutral, and due to that they will start getting clumped. That's where precipitation will happen. So that's where precipitation will happen. So all of them, they will be settled at the bottom due to the neutral charge. There is no negative or positive, because it is getting neutralized by the outside added positively charged ions. Okay na? So that's where precipitation will happen. Now, exactly same thing. When I am adding electrolyte to this, once again they will gain the charge. Once again they will gain the charge. And if you mix it properly, now they will start getting dispersed. That is nothing but basic principle of peptidation. That is the basic principle of peptidation. What is peptidation? Peptidation is a method for the preparation of colloid by dispersing the whatever precipitate is there by adding the electrolyte. That is conversion of a precipitate into a colloidal solution by adding the electrolyte. That's where we have the peptidation. And whatever electrolytes you are adding, they are called as peptizing agents. They are called as peptizing agents. But my point, so these are two important terms. One mark question you can expect. What is peptidation? Then you should tell that peptidation is a process where a precipitate will be converted into a colloids. That is definition for peptidation. It is a process. It's not a molecule. It's a process. What are peptizing agents? Then you should tell that these are the molecules which are used during the peptidation process to convert a precipitate into a colloid. Peptizing agent means it's not a process, it is a molecule. When I am talking about peptidation, I am not talking about the molecule, I am talking about the process. So don't get confused, whatever I am telling. It is a process, it is a molecule. So normally peptizing agent will be electrolytes. Normally peptizing agents will be electrolytes. So this is another method for the preparation of colloids. This is the another method for the preparation of colloids. So this one I have explained. That is only to make two people to understand why after adding the electrolyte there will be peptidation which will take place. The reason is this one, right? Because by adding the electrolyte you are providing charges to the colloids, because of which they will get dispersed. They will move away from each other. That's where we have the role of electrolytes, either in precipitating the colloids or making the precipitate into a colloids. In both the cases we can use the electrolytes. Okay, so these are some of the method for the preparation of colloids. Okay, So these are some of the methods for the preparation of colloids. Which and all method we have discussed? One as chemical method, just now I have discussed. Another one is Bredic's arc method, and the next one is peptidation. Okay, so these are some of the methods which are involved in the preparation of the colloids. All of you have understood? Any doubts? If you don't have any doubts, I will move to the next one. That is purification. Purification of colloids. Next one is purification of colloids. Okay? So still people are coming. Good morning. Fast. Okay? So that's where we have the purification of colloids. So once again I will tell, we have discussed about preparation. Now we are coming to the purification. You have to remember about peptidation and peptizing agents. What is peptidation? Peptidation is the process of converting a precipitate into a colloids by adding the electrolytes. That is called as peptidation. What do you mean by peptizing agents? These are the reagents or chemicals or molecules which are added to the precipitate to convert them into colloids. That's where we have the peptizing agents. So now we will come to next one, purification of colloids. So purification, in the name itself it is there. Unwanted thing we are going to remove from our interested molecule. That is nothing but purification. Right? Say for example at home we will be using AquaGuard or Pureit. So what they will do? They will remove unwanted molecules from the drinking water. So they will make that water fit for the drinking purpose. So same way purification of colloids means where unwanted molecules will be removed from the colloidal solution. So that is nothing but purification. In that, once again, whatever I will be telling, that one I will make it as important. That is for dialysis. First one is dialysis. So now you people might have heard, or biology students might have heard, when kidney is not functioning properly, then they will go for dialysis. They will tell, dialysis ಮಾಡಬೇಕು, kidney ಸರಿ function ಆಗ್ತಾ ಇಲ್ಲ. That's what they will tell. So now when I am talking about dialysis, I am talking about a process. Dialysis is a process where by using the membrane, dialysis membrane, where I will use the dialysis membrane. Normally it will be made up of cellulose which will be cross-linked. They will be using cross-linked cellulose. Normally they will use cross-linked cellulose. Right? So that's where we have the dialysis membrane which they will use. Now the speciality of this membrane will be, if I take a piece of membrane, by our naked eyes we cannot observe pores. Only by using microscope, high resolution microscope, where we can observe these membranes, they will have the pores on their surface. Just like filter paper, they will have the pores. But when I am talking about filter paper, those pores will be of larger size. But here the pore size will be of medium size. That's why they will be having the pores. Now what I will do is, I will take a solution or solvent where this membrane or bag, dialysis bag, will be kept. Okay, it will be kept immersed into the solution. Okay. Now our colloidal solution which has to be purified, it will be present inside the bag. Now whatever unwanted molecules are there, they will be moving out. They will be moving out, and they will get moving to the pure solvent due to the concentration gradient. All of us we know molecules will move from high concentration to low concentration. They will start moving to outside media. Now colloidal particles cannot move outside because their size is greater than this size of this pore. They have the colloidal particles will they have the size which is greater than that of the pores present in the membrane. So therefore what will happen after some time? Inside only colloidal molecules will be there. All the other molecules which are smaller than the colloidal molecules, they will move outside. Now you might be having question, or I will ask the questions to you. Question is very simple. Why we are not worried about the large molecules? Why we are not worried about the large molecules? Anyone? I am talking only about molecules which are smaller than colloidal particles. I am not at all talking about those contaminants which are larger than the colloidal particles. What might be the reason? Anyone? First. You should give the answer fast. Explanation I have given in the beginning of the surface chemistry. Means colloids. Beginning of the surface chemistry only. Anyone? I am only discussing about smaller molecules smaller than colloidal particles. I am telling that since they will be smaller than this pore diameter, they will move out. Since colloids they are having a larger size compared to this pore, they will remain inside. That's where the dialysis principle. Okay? So now why I am not talking about larger molecules? Anyone? That is very simple. When I am talking about larger particles, naturally they will not remain in solution. After some time by itself they will get precipitated, not absorption. After some time, due to their larger size, they will get precipitated. If you go back to the beginning of the class, I took soil in water, then I took milk, then I took salt plus water. So therefore, large molecule, they will not collide. Yes, they will be precipitated. So no need to worry. After it keeps for some time that colloidal solution, by chance, if any large particles are there, they will be precipitated by themselves. Right? But small molecules, they will remain in the solution. That's where we have to separate them from the colloidal particles. For that, best method is dialysis. Okay? Now we have another term which is called as ultrafiltration. It is the extension of the dialysis only. Ultrafiltration. So now what they will do is, in ultrafiltration, they will treat this dialysis membrane with the collodion solution. They will treat this one with the collodion solution. What is collodion solution? Collodion solution is nothing but 4% nitrocellulose or cellulose nitrate solution. 4% cellulose nitrate solution which has been taken in alcohol and ether solution. So that's why it is called as collodion. So when we are going for ultrafiltration, we are going to treat dialysis membrane with the collodion. What is collodion? 4% solution of nitrocellulose or cellulose nitrate solution. Right? Now due to that, what will happen? The pore size will become much more smaller. Pore size will become much more smaller because these molecules will be cross-linked to these pores. So they will decrease the pore size once again. So naturally, much more smaller particles only can be separated in this. So therefore it is called as ultrafiltration. Got my point? That's why it is called as ultrafiltration. So these are some of the methods which is used for the purification of the colloids. These are some of the methods which are used for the purification of the colloids. All of you have understood? So dialysis, keep that one in your mind. So what is dialysis? Dialysis is the one of the method or process for the purification of colloids using dialysis membrane. Using dialysis membrane. What is dialysis membrane? These are the membranes made up of cellulose, cross-linked cellulose, having pores in their structure. Having pores in their structure. Fine. So that's where we have the methods for the purification. Now I am coming to very important part. That is with respect to properties. That is with respect to properties of colloids. That is with respect to properties of colloids. Okay. Now, in the solution topic, we are going to discuss it once again. That is related to colligative property. In the solution, we are going to discuss it once again about the colligative property. Now, same thing we are going to discuss here. What do you mean by colligative properties? Colligative properties means there are four. One is with respect to increase in the or decrease in the freezing point, depression in freezing point, increase in the boiling point, that is elevation in boiling point. Then we are going to discuss about osmosis, that is osmotic pressure. That is nothing but osmotic pressure. And the last one is decrease in vapor pressure. Anyway, I am not going to discuss these things in detail. You people have to discuss this one in detail with respect to solution topic. So for time being, you remember about the colligative properties. So colligative properties are those properties which will be decided by the concentration of the solute. Colligative properties are the properties of the solution which will be decided by the concentration of the solute, not by the nature. So that's where we have the colligative properties. Now, compared to salt solution, what you should remember here is, compared to salt solution, colloids will show the colligative property to less extent. It will show the colligative property to the less extent. Compared to pure solution, I have taken the example of salt solution. Compared to pure solution, colloids will have the less colligative properties, but they will show the colligative properties. Fine. Anyway, in detail about colligative properties, we are going to discuss in the topic solution. Now, whatever I will be telling now, next one, that is important, very, very important. That is nothing but Tyndall effect. That is nothing but Tyndall effect. So Tyndall effect is due to scattering of light. Scattering of light by the colloidal particles. Scattering of light by the colloidal particles. Now it's very simple. Since colloidal particles are the only one which can show the Tyndall effect, because they are the only one which can scatter the light. Much more smaller molecules, like if I take NaCl solution, they cannot show the Tyndall effect because particles are very small. They cannot scatter the light. But when I am talking about milk, yes, they can show the Tyndall effect. Milk can show the Tyndall effect. If you change the angle, you can try it out. You can take a glass of milk, not in steel vessel, I am talking about glass of milk. That also transparent glass should be there. When you put the torch at different angles, you can see the colors. Milk will be colored. So that's where we have the Tyndall effect. That is due to the scattering of light. Sky is blue. That's what Raman effect, right? Sky is blue because scattering of light. Whatever atmosphere, dust particles and all are there, they are going to scatter the light. That's where colloidal solution is the one which has the ability to show the Tyndall effect. So what is Tyndall effect? Tyndall effect is, or why Tyndall effect is there? Tyndall effect is due to the scattering of light by the colloidal particles. In day-to-day life, we are going to observe all these things. For example, you are in a summer, you are sitting in a room, okay? Suddenly door will get opened and sunlight will be entering inside. Now you can observe so many dust particles in the sunlight. If you close this door, then nothing, you will not observe anything. You feel like your atmosphere is very clean. But once again, if you open the door, you can see so many dust particles. So that is because those dust particles, due to larger in size, they will have the scattering of light. Now, Mayank is observing outside, not like that, where complete sunlight is there, it is saturated. I am talking about in a dark room where light is entering through a narrow passage, like a narrow space of the open door or window. Then only you can observe scattering of light by the dust particles. So that's where we have the Tyndall effect, which is one of the important property of the colloidal solution. Fine. So all of you have understood. So particle size will make colloidal solution to make scatter the light. Now what will happen if I take large particle size? Then it will not scatter, it will block the passage of the light. Okay. So scattering is different, blocking the light is different. Normally for scattering of light, particle size should be, why I am giving the answer, why colloidal will be having Tyndall effect, where particle size is near to wavelength of the radiation. One is wavelength of the radiation. That is one thing, very important thing. That's why we can have the Tyndall effect with respect to colloid solution, because whatever particle size is there, it is near or bit less than that of the wavelength of the radiation what you are using, that is visible radiation. Sunlight means whatever we are getting is enriched with visible electromagnetic radiation. So with respect to that wavelength and particle size, so they will be almost same or slightly lesser. That's why they will show the Tyndall effect. Okay, so that is very important one. And another important thing is, that is with respect to anyone, that is with respect to difference in the refractive index. That is another one is difference in the refractive index. So these are the some of the points. So difference in the refractive index of dispersed phase and dispersion medium. So these are the two reasons why colloids will have the Tyndall effect. They can scatter the light. Okay, so that's where we have one of the important one. And whatever next property I will be telling, even that is also very, very important, or you can include another V. So that is Brownian moment or motion. Brownian motion. Tyndall and Brownian both are based on the scientist who has identified. Okay, now Brown is the one who identified this one. Tyndall is the one who identified that particular scattering of the light. Now Brownian motion means it is nothing but random zigzag movement of colloidal particles. They will ask definition for Brownian motion. Then you should tell it is the random zigzag movement of colloidal particles. If you want to represent, it can be like this. Direction can be anything. Okay, random it is. Zigzag, almost jet like that it will go. That's what it is called as zigzag movement of colloidal particles. Now, why Brownian motion will be shown by the colloidal particles? So that is because collision of dispersion phase molecules with the dispersed phase. The reason for Brownian movement is collision between dispersed phase molecules, collision between dispersed phase molecules and dispersion phase molecules. Okay, so due to this collision, they will be moving randomly in zigzag motion. They will be moving randomly in the zigzag motion. All of you have understood? So that's where we have the Brownian movement or Brownian motion. Okay. Now this is very important. Brownian movement. Even Tyndall effect is also very important for your examination point of view. Next part is, as I have told, colloidal solution will have the charge on them. They will have the charge on the surface. Right? Now naturally when I have a silver nitrate, when I will add it to the potassium iodide solution. So I am adding silver nitrate to potassium iodide. Right? That means potassium iodide solution will be dispersion media, silver nitrate will be dispersed phase. Now during that time what will happen? AgI, okay, so which will be surrounded by the negatively charged iodide. It will be surrounded by the negatively charged iodide. Try to understand this properly. I have got silver nitrate. When I will add it to the potassium iodide solution, that means concentration of silver nitrate will be bit less compared to potassium iodide. Right? When I am adding this one to this, now there will be displacement. NO3 minus will be displaced by I minus. That's where I am going to get silver iodide. And this iodide which is in excess, they will be surrounding the silver iodide. So that means there will be formation of a negative charge on the colloidal particles. Right? Now this negative charge, once again it will be bound by the counter ions, that is potassium, which is present in excess. It will be bonded by the counter ion, right? So now this is called as counter ion. Okay, na? So this is surface charge and this is counter ion. Okay, na? Now the question here is, whatever iodide is there, it is static. It will not move here and there. It will be static, but potassium ion is movable. They are not static, they are movable. So that's where, if I observe it carefully, I have got negative charged one layer and I have got positively charged another layer. Right? I have got negative charged one layer and it will be on the positive charge of another layer. Since there is a presence of negative and positive, charge, it will lead to the potential difference. That is nothing but zeta potential, which will be called as zeta potential. This potential difference is called as zeta potential or electrokinetic potential Okay. Now if someone asks you, what do you mean by zeta potential? It is the potential created in a colloidal solution with respect to static charge and movable charge around the colloidal particle is nothing but zeta potential or electrokinetic potential. Therefore it is called as kinetic, because one of the counter ion is movable. They are not static. They are not exactly in that position. They will move here and there. So therefore it is called as electrokinetic potential or zeta potential. So why this potential will be created? That is due to the charge present on the colloidal particles. Whether I am clear? So why this zeta potential will be created? that will be created due to the charge on the colloidal particles. Whether I am clear? Fine. Now, if that is the case, these are some of the properties which we have to discuss. Now we will move to the next one. Another 5 minutes, we will move to the next one. Now we have one thing called as flocculation. We have one word called as flocculation and flocculation value. Flocculation and flocculation value. Okay na? So that's where Purnima, I am not done with the class. Okay na? Another 5 minutes it is there. So flocculation and flocculation value. So flocculation is a process where a colloidal solution will be converted into a precipitate. Flocculation is a process where colloidal solution will be converted into a precipitate. That's where it is called as flocculation. Now flocculation value means it is the amount of electrolyte. It is the amount of electrolyte added. Amount of electrolyte added or required to precipitate the colloids or colloidal solution is nothing but flocculation value. Try to understand this because we are going to have one important rule which is called as Hardy-Sculls rule. That is important. That is based on this. Now what do you mean by flocculation? Flocculation is nothing but converting colloidal solution into precipitate, which I have explained peptidization. That time I have explained this one, but I have not used this word. Okay. Now next one is flocculation value. So flocculation value is nothing but flocculation I am talking about the process. Flocculation value I am talking about the amount. Amount of what? Amount of the electrolyte. Quantity of the electrolyte which is required to bring the precipitation or which is required to bring the flocculation of a colloidal solution. That is nothing but flocculation value. Whether I am clear, all of you have understood? If you have understood this, now Hardy-Sculls rule you are going to explain. I am going to explain which you are going to understand. If you have any confusion here, let me know. Okay? So flocculation value is not a process. Flocculation value is in the name itself it is there. It is a value. It is some quantity, some amount of what? That amount of electrolyte which is required to bring the flocculation of a given colloidal solution or precipitation of a given colloidal solution. Okay? So I think in your textbook they might be using precipitation value also. That is also fine. Flocculation value or precipitation value, whatever it is. Now we have important rule. That is Hardy-Sculls rule. Hardy-Sculls rule. Okay na? Now it tells that flocculation value of a electrolyte will be increased by increasing the valency of the electrolyte. Flocculation value of a electrolyte will be increased by increasing the valency of the electrolyte. By increasing the valency of the electrolyte. Naturally, what do you mean by valency? See, for example, if I take sulfate -2, if I take chloride -1, I will tell that valency of sulfate is more because it is -2, right? Valency of sulfate is more compared to chloride because it is only -1. So therefore, I will make like this. Flocculation value for sulfate will be less compared to chloride, because sulfate is of higher efficient. Flocculation value will be less for here, or I can tell that flocculation capacity of sulfate is efficient. Okay. So in the same way, if I take aluminium plus 3 and if I want to compare with the calcium plus 2 and then with Na plus, then I can tell that aluminium ion is more efficient compared to calcium. Calcium is more efficient compared to Na plus. So that's where Hardy-Sculls rule tells. As the valency increases, its capacity for flocculation will also increase. That means, to short, I require more number of chloride to precipitate compared to sulfate. Or I can tell I require less number of sulfate ions compared to chloride. Same logic. I require less amount of aluminium compared to calcium. So you might be asking question, sir, then why the hell you have written this symbol? That is related to efficiency. Efficiency is going to decrease as you move rightward direction. Efficiency with respect to what? Efficiency with respect to bringing the flocculation. Efficiency is with respect to bringing the flocculation. That's where it's going to decrease as I move in the rightward direction. Fine. All of you have understood? So that's where we have the Hardy-Sculls rule. Any doubt about this? In competitive exams they may ask about Hardy-Sculls rule. They can ask in the competitive exams. So even I can use another ion also, PO4 minus 3. Okay, PO4 minus 3. That means as the valency increases, flocculation capacity will also increase. That's where we have the Hardy-Sculls rule. Got my point? Anyway, I thought today I am going to finish it off, but still another 15 minutes class is there. So that one I will continue tomorrow, and once it is done, I am going to start with another bit easier topic, that is biomolecules. Okay? And for biology students, I will be expecting quick answers from them. CS students should not feel bad. Why biology student? That is because in first year they have studied biomolecules in their biology syllabus. Okay? So today I will stop here. So still another 10-15 minutes class is there to finish the surface chemistry. Then tomorrow we will start with the biomolecules class. So by coming tomorrow you should be ready with Tyndall effect, then Brownian motion, Hardy-Sculls rule and dialysis. These are some of the important concepts which we have discussed. Okay? So take care. Okay, bye. Take care.